Hello everyone, welcome back. This is Gowda.r pursuing my second year engineering at Sri Venkateshwara College of Engineering, Bangalore. And today's video is going to be related to DSA and the topic will be a binary search tree from the research paper. So let's get started. The contents of this presentation include introduction, basic terminology, binary tree, properties of binary tree, types of binary tree, and conclusion. Introduction. A tree is a dynamic non-linear data structure which is an acrylic graph or group having no cycles. This structure is mainly used to represent data containing a hierarchical relationship between elements. The keywords used here are node, root, child, subtree, and sublinks. The binary tree are hierarchical data structures which allow insertion and a fast nearest neighbors reach in one-dimensional data. It can also be inserted of Q-sort and binary search to quickly find the data to the closest points in data array. Its advantages having a single simple structure that allows generalization for more than one dimension, and that is also called as a KD tree. Onto the basic terminologies. The first terminology here is a root. A root is a specially designed node in a tree which has no parent. There can be only one root in a tree. Suppose in this figure you can see that A is a root node. And second terminology here is a node. This is the main component of any tree structure. It stores the actual data along with links to other nodes. In this figure, A, B, C are nodes because these are holding the data elements. Terminology here is a parent. A node having the left child or right child or both is termed as a parent node. Suppose in this figure, here is the figure 2 where node A is a parent of node B and C. Next one comes the child. The immediate successors of node are called the child nodes. A child which is placed at the left side is called the left child, and the child which is placed at the right side is called the right child. In figure 2, node B and C are children of node A. Fifth, leaf. A leaf is a node, the external node which does not have any child node. This figure represents figure 3 where D, E, F and G are the leaf nodes. Sixth one comes the siblings. The child nodes of a given parent node are called siblings. In this figure, node B and C are siblings of node A. Seventh one, path. Each node has to be reachable from the root through a unique sequence of edges called path. The number of edges in a path is called the length of the path. Eighth, level of a node. The level of a node is its distance from the root. The level of the root is defined as 0. The level of all other nodes is more than its parent node. Height of a tree. The height is defined as the maximum number of nodes in a branch of a tree. This is one more than the maximum level of the tree. The height of the tree in figure 4 is 4. Let us know about a rooted tree. A rooted tree is the one which we designate one node as the root. In the figure 4, node A is a root node and figure 4 is a rooted tree. The 11th one is an ordered tree. If in a tree at each level an ordering is defined, then such a tree is called as a ordered tree. Understand what is a binary tree. A binary tree is a rooted tree in which each node has at most two children. Here is a pictorial representation. This is the root node where the data has left and right path, where left again is split into separate node called left child, where again the data is transmitted into left and right path. Again we have a separate root node called the child, and also again the data is split into left and right. Moving on to the properties of binary tree. First one, the number of external nodes is one more than internal nodes. The number of external nodes is at least h plus 1 and at most 2h, where h is the height of a tree. The number of internal nodes is at least h and at most 2h minus 1. The total number of nodes is a binary tree is at least 2h plus 1 and at most 2h plus 1 minus 1. Fifth point, the height of h of a binary tree with n nodes is at least log n plus 1 and at most n. Sixth point, a binary tree with n nodes has exactly n minus 1 edges. The types of binary tree. First type is strictly binary tree. A binary tree is a strictly binary tree if and only if each node has exactly two child nodes or other nodes. A strictly binary tree with n leaves always contains two n minus 1 nodes. Second comes complete binary tree. A binary tree is full or complete binary tree if each non-leaf node has exactly two child nodes and all leaf nodes are at the same level. Type is almost complete binary tree. A tree A binary tree is of depth h is an almost complete binary tree. If any node at level less than d minus 1 has two children, for any node x in the tree with a right descent at level d, x must have left child and every left descendant of x is either a leaf at level d or has two children. An almost complete binary tree with n leaves has two n minus 1 nodes, and an almost binary tree with is completed with n leaves which does not strictly binary tree has two n nodes. Conclusion. The hierarchical file system tell us how does the file get saved and deleted under hierarchical directories. Tree is a data structure which allows you to associate a parent-child relationship between various pieces of data and thus allows us to arrange our records, data and files in hierarchical fashion. The central focus in this paper is to know more about a binary tree. We have learned properties of binary tree and its various types. I hope you guys like the presentation. Thank you.